All right, ladies and gentlemen, we're going to talk about a more specific function that we've been describing. And the function we're going to talk about is what we call a cubic. Okay? A cubic has the equation of x to the third power. So what I want you to understand is anytime you see x to the third power, I want you to think of this graph. This graph that looks like some sort of snake. Okay, this is called a cubic function, as denoted over here onto the side. And anytime you see x to the third, or more specifically, anytime you see a function with a power of 3, I want you to memorize these 3 parent points. Remember, to graph, like we mentioned before, you must have points to start off with. So for powers of 3, you're going to start off with these 3 parent points. -1, -1. All right, so I'm going to put that down here. -1, -1, 0, 0, and 1, 1. We're going to use these points to graph our cubics with transformations. All right, moving on. Some more specific information about cubics. Cubics have the domain of -infinity to positive infinity, which means they go to the left forever and ever, and they go to the right forever and ever. They have a range of -infinity, means they go down forever and ever, and positive infinity, they go up forever and ever. Here's their end behavior. Okay, as x goes to positive infinity, as we go in this direction, the cubic will go to positive infinity. So as we go to the right, the cubic goes up forever. As we go to the left, -infinity, on the left side, our cubic goes down forever. Okay? One thing I need you to remember, our a and b value that we talked about in our previous lesson can change the end behavior, and we'll talk about that in a second. All right, so to summarize this, a cubic function will always have a power of 3. So when you see a power of 3, think cubic function. When you see power of 3, the cubic function, I want you to think about these 3 points and this shape of our graph. All right. Okay, since we are dealing with a specific equation, a cubic, to find or dissect our A, B, H, and K, the locations of A, B, H, and K are pretty much in the same idea, but instead of having like the function f like we did previously, this is going to be in equation form. If you notice, we have the power of 3 here. So when you see that power of 3, that tells you I have a cubic. And once you know it's a cubic, we start with our 3 points, and then we dissect our A, our B, H, and K. Again, the A value multiplies outside parentheses. The B value multiplies with the X. The H value adds or subtracts inside parentheses. The K value will add or subtract outside parentheses. Saying that, they all still do the same thing as we've done before for the general functions. The functions we talked about in the last all transformational graph notes, okay? A still controls vertical stretch and compression, reflection. B controls horizontal stretch and compression, and reflection horizontally. H is a shift of left and right. K shifts up and down. Again, this section here should be all review for you. Okay, let's sketch this graph. At the very top of this slide, you'll notice I just copy and pasted the previous slide up here so you can have this as a reference. I also copy and pasted the basically equation guide up here so you can see where to find A, B, H, and K from your new equation. All right. So before we start, I know I have some steps here, but I always like to talk about the steps before we get going. And that is, make sure you know your reference points, your parent points. Alright, so I'm going to label them here. We got -1, -1, 0, 0. We also got 1, 1. And then the other thing that's very important, I'm going to do this in a very kind of lighter shade, is we have to know the shape of our graph. So the shape of our parent graph, or original graph, looks like a snake. That's very important for later as we go ahead and graph the next graph. Okay? So just like I did in examples on previous notes, I'm going to write down my points. Even though I plotted them, I want to write them down now. So I have 0, 0, 1, 1, and -1, -1. Again, this is not any particular order. I just got to put them down. These are my original points. Okay? Step 1. If you remember, we're going to dissect. We're going to take our equation and dissect or identify in our steps A, B, H, and K. So let's do that off to the side over here. My A value Okay, so where do I find my A value? If you look, you can use this as a reference guide over here. My A value is the number that multiplies outside parentheses. So if you look, if you kind of match this guy with this guy, my A value is going to be 2. Okay? And again, let's look at our notes up here. If the A value is bigger than 1, we have a vertical stretch. So my A value is going to have a vertical stretch. So I'm going to write that in so I can describe. So basically it's going to stretch by 2. And then the other thing I know is that how do I apply my A value? My A value affects my graph by multiplying your Y values. So I'm going to multiply with Y's. Okay? To start that process, I'm going to put my A value here. So I'm multiplying by 2. That's my A value. We are done with A value. Let's go on to B value. So your B value, let's look at our reference until we get comfortable, is the guy, I know it's in fraction form, you can kind of ignore it now, for now, but it's the guy that multiplies inside parentheses with the X. So if you look, my B value is actually 1, but I flip it. The reciprocal of 1 is still 1. There's my B value, and I'm going to write down, there's nothing to do there because it's 1. So if you don't understand what I'm talking about, look at your B value here. If it's equal to 1, none of this stuff happens. Okay? But we do, to apply it to the graph, it does, where are we at? You will multiply your X values with the B value. So we're going to multiply with X's. Okay? Alright, now we're going to go ahead and multiply with the X's times 1. Okay, at this point, before I do my H and K, well, actually, let's just do the H and K so you can keep in line with the steps here. My H and K, my H value, again, if you want, you can kind of match them up here. My H value is inside parentheses, and it's going to be adding, subtracting. So if you look, inside parentheses, it's -1, but we switched the sign of the H value, so instead of -1, it's +1. And what does the H value do? In this case, if you look at your references for H value, translate means shift. It's going to shift right or left. And since it's +1, we're going to shift to the right 1 time. Alright, so we're shifting right 1. And then again, how do I apply this? Add or subtract H from the X value. So we're also going to add or subtract from the x value, x coordinate. Okay, we'll apply those right now. Let's go ahead and now find the k value. So the k value is adding, subtracting outside parentheses. We have -1 here. So -1 is my k value. You don't have to switch signs. And that's going to shift down 1. Okay, and if you look, your k value shifts up or down, and it adds or subtracts to the y value. So plus, minus the y coordinate. Alright, so that is basically what I want you to do for step 1. Step 2, we're going to perform all these in order. Multiply the a value, b value, h value, then k value. We'll kind of do it 2, 3, 4, and 5, kind of almost all at once. 2 and 3 at the same time, step 4 and 5 at the same time. Okay? So, let's do this. After I apply my a value, which I've already written up here, here's my b value, here's my a value. I'm going to multiply here and multiply here, so I get my new points. It's going to be 0, 0, 1, 2, -1, -2. Okay, so we kind of just did step 2 and 3. Now we're going to do steps 4 and 5 at the same time. My h goes with my x's. So my h is going to be +1. My k is going to be -1. And then we get our final point. And then we're going to plot them. So adding 1 to the x's, subtracting 1 from the y's. So we got 1, -1, 2, 1, and 0, -3. These guys here are your final points. So final point, and I'm going to plot them. As we plot them, you should notice whatever you described here, we're going to have a vertical stretch, and we're going to shift over 1, down 1. So let's see if that happens. So I'm going to have 1, -1. So 1, -1. That big dot there. Then we're going to have 2, 1. 2, 1. And 0, -3. Okay, so I know it looks like just 3 dots, but remember, we got to keep the cubic shape. The cubic shape is this kind of curvy vertical line here, okay? So as I plot it, we kind of want to have that curvy vertical line. All right, that is my graph. The domain, of course, I'm going to plot those in, but you should be able to remember these. This is a review. Domain is how wide my graph is. So my graph is wide as -infinity and +infinity. My range is how tall my graph is. So it goes down forever. So that, again, is -infinity. Goes up forever, +infinity. And then my end behavior. On the x to +infinity, so on the x, we're going to the right side. On the right side of my graph is going up forever, so it goes up to +infinity. And then my graph, my x on the left sides, so my x is on the left side, that's -infinity on the left, it goes down to -infinity. Alright, and that's how we graph. So go ahead and pause the video, try example B, and see how you do. Alright, let's do this a little faster. So my A value, -1/2. My B value, is 1. My H value, -2. My K value is +1. So just to describe this is going to be a vertical compression and also a vertical flip, a reflection over the x-axis. So in other words, when we're done with the math, the top becomes the bottom becomes the top. Okay? And of course, the A value multiplies with the Y's. Nothing's happening for the B. The H value is a shift backwards 2 times. All right. And this is going to be a shift up 1 time. All right. So we found our A, B, H, and K. We've described it here. Now, let's go ahead and start multiplying the A and B first. So we're going to go the A and B. The A goes with the Y's. So we're going to multiply by -1/2. So -1/2 here. And multiply by 1 here. Okay. So let's do that. I'll put the result in blue. Okay, so now we got these new points after A and B. Now we're going to apply H and K. H adds and subtract to the x's. K adds and subtract to the y's. So let's put that in. So the h's go with the -2 here, goes with the x's. And the +1 goes here with the y's. Let's go ahead and do that math, and we get our final points. So these are our final points here. Okay, just be careful when you're adding and subtracting with these fractions. Use your calculator if you need to, but these is the problems you should have here. So let's graph this. -2, 1. Here, -1 and 1/2, so -1. And then we're going to go down 1/2, so about right there. Sorry, let's repeat that. -1, and we're going to go up 1/2, so -1, up 1/2. So right in the middle there. And then we have -3 and 1 and 1/2, so -3, so it's 1 and 1/2 more. So I know these look like straight lines, but remember, we got to keep this squiggly line with the understanding, because we described it, it has flipped upside down because of the A value being negative. Alright, so we have a vertical flip, which means it's going to go in the opposite direction. Okay, so let's see and make sure everything happened that was supposed to happen. So we had a vertical compression. If you notice, these dots are flatter than these dots, so they got flattened closer to each other. Okay, that's the vertical compression. We had a vertical flip. My graph is kind of upside down now. We shifted left 2 spaces, and we also shifted up 1. So all those things happened. So now we can go ahead and answer the domain and range. So my domain here, how wide is my graph? It's still from -infinity to +infinity. That didn't change. Okay, my range, it still goes down all the way forever and goes up forever. So it's the tallness of my graph is -infinity to +infinity. And now my end behavior. So if we look at our end behavior, x to +infinity. So +infinity is on this side. So what is my graph doing on the right side? On the right side, it's going down, and it doesn't stop going down. So this would be -infinity. Now over here, x to negative infinity, so on the left side of the x, what's my graph doing? It's going up to positive infinity. And we're done.